In the world of data, getting a SQL query to just work, that's one thing. But writing a query that's fast, efficient, and honestly professional, that is a whole different ballgame. Today, we're going to bridge that gap. We're going to take you from being an SQL scripter to a true SQL craftsman.
Oh yeah, you've been there, right? You hit run, and then you just wait. Maybe you go grab a coffee. Or worse, you get that nasty surprise on your next cloud bill. That feeling, that slow, expensive query is a pain we all know. And it's exactly what we're going to tackle today.
See, a good enough query is never really good enough. It doesn't just waste your time. It slows down the whole team. It makes apps feel sluggish, and it costs real, actual money in wasted computer power. That's why getting good at this isn't just a nice-to-have skill. It is absolutely essential.
So, where do we even begin? Well, funnily enough, not with the query itself. We start with the foundation it's all built on, because truly great performance, it always starts with a great structure.
Okay, first things first. Let's get to fundamental ideas straight. DDL and DML. Think of DDL as the architect's blueprint. These are the commands like create, alter, and drop that literally build and shape the structure of your database. DML, on the other hand, is for working with the data inside that structure. The select, insert, and update commands. Knowing which is key to understanding how everything fits together. Next up is this idea called normalization. You can think of it as the art of designing really clean, really efficient tables. And the goal is incredibly simple. Store each piece of information in only one place. That's it. This one simple rule prevents all sorts of errors down the line and keeps your data trustworthy.
Now, normalization follows a few key rules, and honestly, these are the big three you need to know. First, normal form means every cell has to hold a single atomic value. No stuffing lists in there. Second, all the columns in a table have to depend on the entire primary key, not just a piece of it. And third, normal form says no column should depend on another column that isn't the key, like a street address shouldn't determine the zip code. These rules are the blueprint for a solid data model.
All right, with that solid foundation in place, let's open up the core toolbox. These are the day-to-day techniques that are going to give you the biggest and fastest performance wins right out of the gate.
The select all strap trap. Come on, we've all done it. It's so easy, but it is a performance killer. Why? Because you're making the database grab every single column and haul it over the network, wasting memory and bandwidth. The fix is so simple. Just specify the exact columns you actually need. It's probably the quickest win you can get.
So, union and union all, they both combine results from two queries, but there's a huge difference under the hood. Union automatically checks for and removes any duplicate rows, which means it has to do an expensive sorting operation. Union all just stacks the results on top of each other, duplicates and all. The takeaway here, if you know you don't have duplicates or you just don't care, union all is always going to be faster.
When you're filtering data, you've got choices. In is totally fine if you have a small fixed list of values. But if you're checking against a big subquery, exists is almost always the champion. The reason is simple. Exists is lazy in the best way possible. It stops searching the second it finds a single match, whereas in often has to process the entire list every single time.
Joins are the absolute heart and soul of SQL. Your go-to, most of the time, should be an inner join. It only gives you rows that have a match in both tables. Now, if you need every single record from the left table, even if there's no match on the right, that's when you reach for a left join. A right join is just the mirror image of that. And a full outer join, well, you'll rarely use it as it just grabs everything from both sides. Choosing the right one isn't just about getting the right answer, it's critical for performance.
Okay, we've got the core tools down. Now let's upgrade to the power tools. These are the techniques that really separate the scripter from the true craftsman, the ones that let you solve really complex problems with elegance and speed.
Let's talk about common table expressions, or CTEs. These things are an absolute game changer for making your code readable. Just think of a CTE as a temporary, named scratch pad. You define it once at the top with a with clause, and then you can refer to that little result set later in your query, almost like it's a real table.
And here you can see why it's so great. On the left, you've got this tangled mess of nested subqueries. Good luck figuring that out in 6 months. On the right, it's the exact same logic, but broken down into clean sequential steps using CTEs. It's not always magically faster, but it is infinitely easier to read, to debug, and to maintain. Your future self will absolutely thank you for using these.
Window functions, oh man, these are like a superpower. They let you do calculations across a window of rows, things like running totals, moving averages, or ranking your results. But, and this is the magic part, they do it without collapsing all your rows like a group by does. This just unlocks a whole new universe of analysis you can do right inside your SQL.
But here's the thing. Being an SQL craftsman isn't just about the code you punch into the keyboard. It's about how you think. It's about the habits and the strategies that define what it means to be a real professional.
A real craftsman thinks about the whole life cycle of the data. That means focusing on these 4 key pillars. You've got monitoring, so you know how your queries are actually performing. You have documentation, so other people and you can understand your work later. You've got scalability to make sure your code can handle future growth. And of course, security to protect the data itself.
This quote right here really gets to the heart of it. If you aren't actively monitoring how your queries are doing, you're just flying blind. You're guessing. Real, meaningful optimization always starts with measurement. So how do you do that?
Well, the good news is every major data platform gives you some powerful tools for exactly this. If you're on Snowflake, you've got the Query Profiler. Over in BigQuery, you can dig into the execution details. In Redshift, there's a query plan visualizer. Whatever you're using, get to know its monitoring tools. They will literally show you exactly where the problems are.
And finally, a pro is always thinking ahead. It's not just about solving today's problem. It's about designing something that can handle tomorrow's scale. Things like partitioning, for example, which breaks a giant table into smaller, more manageable chunks, often by date. This is how you keep your queries snappy, even when your data volume just explodes.
Wow, okay, we have covered a lot of ground. We went from the basic principles of database design all the way to advanced techniques and the professional mindset you need to really excel. That shift from scripter to craftsman, it's all about being deliberate and thoughtful in everything you do.
And that's really the main takeaway here. This isn't about finding some single magic trick or a secret hack. It's about consistently applying these best practices over and over until they just become second nature. It's a habit that you build, one query at a time.
So how do you start? Simple. You start with one small change, one new habit.
So, I'm going to leave you with this question. What is the one optimization habit you are going to build this week? Maybe it's finally, for good, abandoning Select Star. Or maybe it's trying out your platform's query profiler for the first time. Or maybe it's taking one of those ugly subqueries and refactoring it into a clean CTE. Just pick one thing, make it your focus. That right there is how the journey to becoming an SQL craftsman really begins.